So, hello everybody. My name is Loïc Joly. I'm working for a company named SonarSource, and we are developing static analysis tools for C++ and 24 other languages. But today I'm going to focus on C++, obviously. And I'm also part of the French representation for ISO C++. And since a few years, I've been working on a new version of the MISRA standard, and I'm going to talk to you about this today. So before I directly start, do you already know or use MISRA? Can you please raise your hand so that I can get a little bit, not that much. You're aware of it, obviously, but not much. Okay, so I'm going to start by giving a little bit of background before going to the meat of my talk. So first, what is MISRA? MISRA, as you all know, C++ is a large language. And being a large language, it's possible to use it to do wonderful things, and it's possible to use it to do crappy stuff. And when you are working on safety critical code, you want to stay aware of the crappy stuff. And every company, whatever it needs, usually don't use all of C++. It uses a subset. And what MISRA is trying to do is to try to define a subset of C++, which is safe to use for safety critical code. And it's so it's a set of guidelines that says you should not do that, basically. That makes something which is deemed unsafe. And the root of MISRA is the automotive industry. And basically all car builders, except maybe Tesla, at some time want the subcontractors to use MISRA when they write code that is going to be embedded on the car. Maybe not for entertainment for the children at the back in the back, but everything which has impact on the safety, they ask people to write following MISRA guidelines. And there are many sets of guidelines for C++. And any company basically has a set of guidelines for C++. Sometimes it's written, sometimes it's more like pass from one wise guy to a less wise guy so that it becomes wiser. But every company has a set of guidelines. And MISRA is just one of the sets that happen to have some success and to be followed by people, even by people who are not in safety critical domain. And the current version of MISRA for C++ is MISRA C++ 2008. That sounds crazy. 2008. C++ was so different in 2008, and it's even worse than that. It was written in 2008, but it was written by people who had a bigger background in C than in C++. So part of MISRA was written like, oh, this fancy template stuff, maybe I don't trust it. So even if it was written in 2008, it was finished in 2008. It was started before, and it was started with a mindset which is even from before. So that's why this talk is, it's no longer going to be you're going to pass MISRA. We change it, we try to update it, and I want to show you what's going to come soon. So I think it's important to show what is the relationship between MISRA and other sets of guidelines. First, MISRA started with MISRA C, because serious people and embedded softwares do C, they don't do fancy C++ stuff at that time. So MISRA C 98, which then a new version, 2004, a new version, 2012. They are working mostly on a new version now. I don't know what's the schedule of MISRA C, but C is a language which is not moving a lot. So MISRA C does not have to move a lot either. So it's basically stable and not going to change soon. Then out of MISRA C, some other guidelines were extracted. Maybe you've heard of the Joint Strike Fighter, yeah, the stuff for planes for Lockheed Martin. So it was inspired from MISRA C, but it was C++. And then there was MISRA C++ 2008, which was also inspired from MISRA C. You could see some common guidelines between those two. And then there was this AUTOSAR standard, and this set of guidelines was not something that was planned on purpose. It was more like people wanting to write an AUTOSAR set of software for the car to communicate between the cars, to organize different parts inside of the car, and they wanted to use C++14 at that time, but they could not because of some guidelines in MISRA C++ 2008. One of them being that you should use the standard at the time, which was C++ 2003. So they could not directly use MISRA. So a subgroup of the AUTOSAR consortium set up creating a new set of guidelines, updated, modernized, to be able to write code that makes sense at that time. And then there are other guidelines which are totally unrelated, but for MISRA C++ 2020X, X meaning that hopefully it might be 2 or 3, probably not later, hopefully. So we took all those sources of inspiration to put it into the new version of MISRA C++. And we, especially the AUTOSAR part, we took into account every guideline in AUTOSAR to see if we thought it was valuable or not, or if it should be updated. But all of them were taken into account. And part of people who work in MISRA C++ used to work on this AUTOSAR guideline. And the AUTOSAR consortium made an announcement maybe 2 years ago that they do not plan to publish any new version of AUTOSAR. They will switch back to MISRA when MISRA will be ready. And so we've been working on that. I've been working on this version for, I think, 3 to 4 years now. It started before, but it's right now we are getting closer to the finish line. There's been some open reviews for the new version of, not for every guidelines, but for quite some guidelines. You could register and then publish your comments on it. So it's really getting close to the end, hopefully. And there is also a collaboration between WG23 of the ISO committee, which is concerned about, I don't remember the official name of it, but basically about safety critical software at the ISO level. And there is some collaboration between the MISRA group and this group. So in this talk, I'm just going to present some old MISRA rules that try to address one problem with C++, and the new version of the equivalent MISRA rule that address the same topic, but in a different way, just to show you how it evolves. And of course, as I said, the new version of MISRA is not published. So when I said this is how it's going to be, this is the current state of MISRA, but it may change before it is published. So you should not you should not believe that if you write software that way, it's going to be compliant with the next MISRA standard. And before I go there, I would just like to emphasize some of the design goals of MISRA, because it's impossible to correctly understand a set of guidelines if you don't know why they were put in place and with which mindset. So the first goal, I already said it, it's to focus on safety only. So anything which is more stylistic should not be part of MISRA. And so MISRA will not say you that you should use tabs or spaces, for example. It's purely stylistic. There is no safety implication with that. MISRA is going to be silent about it. And so it means that if you want to write some code, it's good to use MISRA guidelines, especially if you're writing safety critical code, but it's not going to be enough. You should also use other guidelines that comes from other sources. It's not supposed to be covering all aspects of the software development. Then the way MISRA is written, it's not telling you how to write code. It's telling you how not to write bad code. So it's not going to tell you that you should write a class with this and this. It just tells you if you write a class with a destructor and no copy constructor, you are not conformant with MISRA, for example. I'm going to go a little bit more details on this rule later on. And then one of the things that MISRA hates is undefined behavior. So every time there is a place in the standard which is undefined behavior, MISRA tries to prevent it by restricting the way you can write code, even if in some cases it means that the code you are allowed to write to be MISRA compliant is going to be a little bit more clumsy than you could have written without MISRA. Even if it's painful, we are talking about safety critical code, so maybe the code is not the smallest that you could write, but it should be okay because of what's at stake there. And for the same reason, usually in this domain, people prefer explicitness over terseness. So there are some guidelines that makes you be more explicit about what happens in your code, so that when someone reviews it, there is no misunderstanding about what the code is doing. And another point of MISRA is that every guideline written in MISRA should be tool checkable. So when I mean tool checkable, you may have heard of Rice theorem, or maybe you may have heard of the halting problem. It doesn't mean that a tool will detect all bad usage of bad code, because it's theoretically impossible. Like if there was a guideline in MISRA that says that every code should stop at some time, having a tool that detects that would be solving the halting problem. And we know it's not possible. So when I say that all guidelines should be tool checkables, it means that it should be defined accurately enough that a tool knows exactly what to look for. Maybe it cannot look for it because of these theoretical reasons, but at least it should be clearly defined, and two different tools, maybe they will not detect exactly the same bad situation because of limitations due to these limits, but at least the tool vendors should agree that, yes, this is a case that we should detect, or no, this is a case that we should not detect. So tool checkability is very important. And if you look, for example, at a set of guidelines like the C++ core guideline, they are not designed to be tool checkable. They are designed to be human readable and human understandable, which is great, except that sometimes it's good to have a tool to help you. And especially when you are doing code review, it's good to have a tool that already detects everything locally, so that you can correct everything, so that when you go to the expensive stage of having a manual code review, you already removed all the small details that don't deserve to have manual code review. Another point is decidability. I already spoke of it. When a rule is said that it's decidable, it means that it doesn't have the problem I talked about with the halting problem. A decidable rule is basically a rule which is focused on the syntax of the code. Like, I don't know, I'm going to invent something crazy, like you should, it's not in MISRA, but if there was a rule like you should put public function before private function, this is totally checkable, decidable. There is no problem to detect that if it's respected or not. But if you have a rule like you should not have double delete, this is not decidable, because you can write arbitrarily complex code for which no tool can decide if the code has double delete or not. And another point which was very important, so I'm going to do a little bit of personal background there. When I started, so I'm working in a company that writes static analysis tools. And when I started to implement rules for MISRA, I hated it. I really hated it for two reasons. First, it was MISRA C++ 2008. And second is they seem crazy. And to me, respecting some of those rules meant writing bad code, in my opinion. So I was writing a tool that was saying other developers to write code that I believe was of bad quality. And so I went into the MISRA group to try to improve the situation. And I discovered that there was two reasons. One was that, yes, some rules were bad because old code, because mistakes of the past. But some tools, I just did not understand them. And the main reason why I did not understand the rule is this last point. It's when MISRA says you should not write code in this way, it doesn't say that you should not do it. It just says that by default, you should not do it unless you have a good reason to do it. And if you think you have a good reason to do it, just write it and go through a formal deviation process, which means especially that you will have other people look at what you did, look that you deviated from a MISRA rule, and this other guy, which should be probably more experienced than you are, will say, yes, I agree that in this case, it was relevant to deviate from MISRA. And this is important because I will show you a rule or two later when if you read the rules, you say it's crazy. I cannot write code without deviating from the rule. And that's fine. You should deviate, but you should be careful when you deviate. You should have additional process when you deviate from the rule. And this mindset, I think, is very important when you read MISRA guidelines. It's very important to have this mindset. Otherwise, you will just get crazy at the rule and say, how am I supposed to write software with this rule? And there is an exception which is not used a lot, which is mandatory rules. Those cannot be deviated, but it almost never happens. It's only when the rule clearly leads to undefined behavior in all cases that it's mandatory. So the first rule, an easy one to get started. MISRA 2008 about null pointers. The rule told that you should not use the literal 0 for null pointers. Instead, you should use the macro null. Why? Because it's more readable and there is less risk of confusion by the user. And of course, you know that since C++ 11, there's a better way. So just simple upgrade. We now said that every case you are using the null pointer constant, it should be written null PTR. And we go one step further, which is you should never use the macro null. Because there could be cases in your code when you use null and it was an integer. We don't want that. Null should never be used. So I think this rule is not controversial. It's decidable. It's a nice one. It makes you write code that clearly states the intent. It helps the compiler to select the right overload. So yeah. Next one, a little bit more interesting one. About unused function parameters. MISRA really don't like when you write code that you don't use. Because it could, if you don't use it, maybe it contains some hidden bugs, maybe it's useless, why do that? They don't like it. So there was a rule that says that in a function, there should be no unused parameters. Well, in non-virtual functions, because of course, if you have a virtual function, maybe for some overrides you will use them, and for some other overrides you will not use them. And then another exception, because callbacks functions, it could be the same. You have a function which is used as a callback, and some of the candidates for the callback will use the parameters, and some other candidates will not use the parameters. Except that the notion of callback was not clearly defined. And we know that with templates, almost any function can be a callback. It's not, a callback is not just a function pointer. It's just if you instantiate your template with a specific type, you end up calling a specific function. And it's a rule that was not really fitting the spirit of C++. One part of the spirit of C++ is that you have the duck typing. Functions that look the same should be replaceable, and you can write a template that use any version of those functions, and it should be almost transparent. And so in the spirit of C++, the prototype of a function is something important, and you should respect this shape of the function, even if it means that you are going to have one parameter which is not used. And in terms of tool checkability, because the notion of callback was not clearly defined, it was not also easy to detect what it meant to be a callback. So new version. All name function parameters should be used at least once. So no more exception for virtual functions, no more exception for callbacks. Okay, I said the rule was too strict. Did we make it stricter? No. All named function parameters should be used at least once. There is a very common pattern, which is if you have a function parameter with no name, of course you are not using it. And it's explicit for the user. It's very visible that you are not going to use it because you cannot use it. It does not have a name. So what we wanted to prevent with the previous version of the rule was an unintended parameter, a parameter that was supposed to be used, but by mistake was not used. And here it's not what's going to happen. You have a parameter. If you don't give it a name, you clearly say that you don't want to use it. So it's okay. So we changed the rule that way. And you could use unused parameter, unnamed parameters, or in some cases when you have a parameter which is used in debug build but not in release build or this kind of stuff, you could also decorate the parameter with the maybe unused attribute, which also handles this situation. Okay. Next rule. it's not just a rule, it's a, well, it was a rule, it's going to be a set of rules now about dynamic memory management. There was one rule in all MISRA which says dynamic heap memory allocation should not be used. And the focus of that was mostly that safety critical software is very often embedded software where you want to have strict limits for how long it takes to perform an operation. And typically doing a new, it's very hard to have a strict limit, an upper bound of the execution time of new. And the second point is you could have memory exhaustion, you could have memory fragmentation. All of that means that it's not so easy to use dynamic memory in this kind of software. But it does not make sense for all kind of safety critical software. It depends on the hardware you run on. It depends on what you're trying to do. And when MISRA was written initially, the kind of software that I had in mind was a software for ABS, anti-blocking system, which is quite simple. Now, the kind of software that we have in mind when we write software for automotive industry is autonomous vehicle. So it's more complex. It needs more data. It needs to have complex algorithm. It needs to mix the information coming from many kind of different sensors. Having everything, mandating that everything is statically allocated has some drawbacks too. For example, if you detect your surrounding environment and you said that I'm going to have a statically allocated array of 10 cars around me, what happens if you are in a traffic jam in the middle of Place de l'Étoile in Paris, where you could easily have twice as many cars around you? So there are some limits, of course, but this rule did not really feel nice. And another point is, I said previously that any rule could be deviated. And if it was deviated, this rule, we didn't say anything more in MISRA 2008. But still, even if you do dynamic memory allocation, there are good practices that you should follow. So in 2020X, it was changed to have now not just one rule, but a set of rules. The same rule as before, because for some software it makes sense. It's still under discussion if it will be kept or not. I don't know what is the current status because I missed the last meeting, but maybe it's still going to be the same rule as before, just because for some software it makes sense. And then there are another set of rules. First one is there is memory management and there is advanced memory management. This advanced memory management is when you are playing with the lifetime of objects, like placement new. Who really needs to write placement new? The guy who writes stud vector, and only him almost. You should not use placement new in your code anywhere. Stud lambda. If you can explain me what stud lambda means, I would be very happy. I've read the specification of stud lambda several times. It's still that corner to me. I know some cases when you should use it, but yeah, it's so complex. There is the notion of overline types. So overload of new when you can specify additional parameters, this kind of stuff. This is too complex for normal software. And once again, it doesn't mean that you're not allowed to use it. It means that if you decide you want to use it, this piece of code will require review by a specialist who can vouch that this is written correctly. And that's perfectly fine to me, because if I ever wrote code with stud lambda, I would probably ask to someone who knows what is really doing about it if I can't find someone like that, which could be difficult. So another kind of rule, which means that even if you do dynamic memory allocation, don't do this kind of crazy stuff unless you really need to go crazy. Next one, a pointer to an incomplete class shall not be deleted, because if you do that, it's undefined behavior. Okay, clear, easy to detect. I don't think this requires any more comments. Next one, dynamic memory shall be managed automatically. Oh yes, we are doing C++11 at least. We don't do new and delete. We use smart pointers. So this is what this rule is about. When you allocate memory, do it with make unique, do it with vector. Don't use new square brackets. Please don't use ** when you are manipulating strings. Please, please, please. Even if you just do this kind of, if you have a code which does not respect that and you make it respect that, it will change your life, and for the good. So this other rule, which is not targeting a same subject as before exactly. It's not targeting directly memory exhaustion. It's targeting memory bugs, but not in a way that we actually detect the bugs, but in a way that if we follow this rule, the bug will just not happen, which is better because detecting a memory bug is not decidable, which means that any tool will have lots of false positive and false negative. It's hard to do that. Detecting this, piece of cake, and it prevents the bug and it makes the code easier to read. Next one is, it's not, I don't think it's quite controversial. It's if you define your own new and delete, you should match them, because if you have your own custom new but not the matching custom delete, it's going to be UB if you are using it. So we replace one rule that was strict, but that did not really care about what happened when you deviate from it, by a set of rules that tries to cover the full situation there. Next one, single entry, single exit. I don't know if you have heard of it, if you've been unlucky enough to hear about it. So it's a rule that says a function should have a single point of exit at the end of the function. So when you're searching for an item, you cannot just have a loop, and if you find it, you return the value. This does not respect single entry, single exit. What this rule says is that instead of that, you should have a Boolean found, and in your loop condition, you have and not found, so that you can break from the loop early if you found the object and have only one return at the end. It's ugly. And the problem is that it's required by IUC standard. And it's very funny because the full content of this standard is about generic requirement, like you should test your code. You should make sure that you hire people with the right level of qualification. And there is only one stuff that talks about code itself, and it's this, single entry, single exit. And almost everybody agrees that it's not that good. And there was a related function which was about, a related guideline which was about set jump and long jump. And this, yes, you should not use them. It's not useful. So what about 2020X? Well, we keep the stuff about set jump, long jump, because this one was good, but we removed this requirement. And really, it was... But to be able to remove this requirement, we make a lot of effort. First, we went to the guy who wrote this other standard, which is an official standard that people in the industry should respect. And we asked them, okay, what do you exactly mean by single exit? And basically the answer we got was, why are you asking us so complex questions? Okay, because you are constraining people who are writing software all over the world, whatever the language. So this is why we're asking the question. Well, it's too technical for us. Why did you write it in the first place then? Okay, I'm going to... So we looked further. We looked when this kind of rule was established. It was established at the time when there was no structured programming. It was established at the time when the only instruction you had was jumping. And basically what we claim now is that by default, C++ respects this guideline, because if you do a return from inside of a function, you will always go back to one exit point, which is the caller of the function. So if you just look at the way the rule is written, single exit as okay, single entry is not a problem until we have coroutines, but MISRA C++ 2020X is about C++ 17, so we don't have to think about coroutines yet. So single entry is not a problem. The problem is single exit. And people have read single exit as you should have only one return keyword in a function. But when we try to look at the why behind this single exit, this is not what it's about. It's about structured programming. It's about the fact that when you exit a function, you should know where you are going back. And even if you have several returns in your function, you're always going back to the same point, to the color of the function. So according to this interpretation, which I believe, and we believe was the correct one, we can have several return and still claim that your code follows single entry, single exit from the philosophical point of view. All sorts of languages are the same nowadays. So if other languages say that they should have only one return, maybe they should try to change their mindset about it. And I'm pretty sure that this change that we did will, I mean, people who write code according to MISRA, I'm pretty sure that they will love us for that. Yeah. Yeah, that's what I say. We didn't think about coroutines yet because we are focusing C++17. And we'll see what happens with coroutines. I don't know, really. It's for loops. So in MISRA 2008, there were lots of rules about for loops. I'm not going to read all the details about it, but basically what did they say? They said that a for loop should increment with a fixed step and do nothing else. Why? Because the purpose is to make sure that the loop will end, basically. And one way to ensure that it will end is it restricts a lot what can be written as a for loop. So it has the notion of there should be one and only one loop counter. The loop counter should be incremented in the third part of the for and nowhere else, and this kind of stuff by a fixed increment, which does not depend on the body of the for, this kind of stuff. So what happened? In all industries where people have to write MISRA compliant code, they never wrote for loops. They wrote while loops, which didn't have any restriction. So, and this really restricts the way we can write a for loop. So how did we change it? Oops. Well, we went further. We just say, you should never write while loops, for loops, do while loops. Never. Of course, it's MISRA, so when you say we should not, it means that if you have to do it, you can do it, but you should be careful. Why? Because those loops are more complex to write than typical code. If you use a range-based for loop to iterate on a collection, it's deadly. It's easy to do that. There is no risk of going one step too far on one step before. You should write code using algorithms. They have a higher level of abstraction and they describe better what you are doing. Instead of writing a loop, write a search, write a any of, write a rotate. So what we say basically is that for common cases, there are ways to write loops without using those low-level looping structures. You should use those ways to write loops. And in the other cases, well, you deviate, but that's good because it means that someone else will have to check that your loop is going to end. It's not going to loop over the same element over and over again. It requires basically all loops deserve special love and several people to look at them. We have a few exceptions because we know this can be harsh and maybe not appreciated by everybody. So we added a few exceptions. So for example, we added a very strict version of the iterating over integral range. But just this, you cannot modify I inside of the body. And if you do it like way, basically this is like the previous set of rules, but even more strict. We allow a while true because having an infinite loop on purpose is something that makes sense in many software. And it's obvious that it's infinite. It's not a hidden infinite loop. It's an explicit infinite loop. It's fine. We allow looping of a volatile variable because for embedded software, it's something that is quite common. And we also allow this do while false, which is a trick which can be used a lot by some macros So we allow this specific pattern. So instead of trying to have a generic rule which did not really fit anybody's need well and which had a very easy workaround, which is use while instead of for, we just prevent all versions because there is better solution, which is range bus for loop and algorithms. And we just allow a few very specific patterns. I expect this rule to be controversial, but I still believe that it's better than the previous situation. Rule of 3. Oh, why is this slide empty? But because there was nothing about rule of 3 in MISRA C++ 2008. Nothing about it. So the change is we introduced it, except that it's no longer rule of 3, it's rule of 5 or rule of 0. And when I started to look at it, I believe it would be an easy rule to add. I mean, everybody knows it. You should write all 5 functions or 0 of them. It's easy. Actually, it's not so easy. It's easy to describe it that way in a book for a human reader. But don't forget that we want the rule to be tool checkable. And there are some exceptions. There are some special cases. And so we had to be more accurate in what we described. So basically, this rule of 0, rule of 5, comes in 3 parts. First part is which function should, it's not about the function, it's about which capability should the class have. So we have, for example, we say in this array that we cannot have a type which is copy constructible but not move constructible. If you can copy it, you can move it. Otherwise, it's going to break many assumptions by many user classes. So basically, and we don't care how you make it move constructible. It can be move constructible because you wrote a move constructor, because you didn't do anything, and by default it is, because all the members allow move construction. There can be many ways to achieve the fact that the class is move constructible. But what we say is that if it is move constructible and move assignable, then it can be either not copy constructible, not copy assignable, or both copy constructible, copy assignable. These are basically what you do when you write a class. This rule, I don't expect it to trigger very often, except for the case when you, not even this. No, sorry, the next part might trigger more often, but if you don't go too crazy when writing a class, you should not have to do anything to respect this part of the rule. It's what everybody is doing anyway. Second part of the rule, if you have customized the destructor for your class, you need to have customized copy and move operation. So this part is basically 5 or 0, and this part is more specifically rule of 5. If you customize the destructor, you have to customize the other operation. You cannot rely on the compiler generated ones. And last part of the rule, it's in an inheritance hierarchy. A public base class should be one of those. So it can be an aggregate, because there are some use cases when you just want an aggregate to have aggregate initialization. It can be with a protected non-virtual destructor, when you don't intend to create object to manipulate object to destroy base class object through the base class. But most of the time, it's going to be a public virtual destructor. So this is the most common case, and that's already what we've been saying in the C++ community for years. When you have a base class, you should have a virtual destructor to the base class. And most of the time, it should be equal default. Because if it's not equal default, it's going to be customized destructor, which means that you will have to take care of the other operations. Okay. Next one, underlying type. So if you don't know MISRA C++ 2008, you are very lucky, because you don't know this. This underlying type stuff is trying to put in place a type system in parallel to the C++ type system that makes numeric operations safer to use. And so it has basically 2 notions. It says that an expression has an underlying type. So an expression has a type, which is what C++ says, but it also has an underlying type, which is what MISRA says. And it has the notion of C value, which is the value that is obtained from some kind of expression, and then it restricts what can be done with underlying types and C values. If you know MISRA C, there was the essential type model in MISRA C, which is basically the same, just a different name. So why did we do that? Well, because arithmetic conversion can be surprising. And now I'm going to rest a little bit, and I'm going to ask you to work a little bit with a small quiz to show you how complex they can be. So you can go to this menti.com website and enter the code which is there. And I'm not sure why it's not started. I should have a... Okay, it's working now. And there you will be able to register to the quiz. It's only 3 questions. And I'm not going to show names. I just want to see how many people get the right answer. This is my main goal. So don't be afraid, don't be shy. 8 people, 9. Okay, waiting a few more seconds. Okay, let's get started. Okay, and you all have a nice avatar, but I will not show it. So let's get ready. Fifteen seconds. Oh, it's pretty evenly distributed. But the right answer wins. So it means that at least it's a good sign that the right answer wins, but there are quite many people who give a wrong answer. Even this one, I didn't expect it this one. So let's look again at the code. The tricky point here is that you have an 8-bit value, but when you are going to get the complement of this 8-bit value, it's going to be promoted. And on typical system, it's going to be promoted. So it's going to be promoted to an int, which on typical system is 32 bits. So then when you are shifting, you are not only shifting the... So this one, if you just flipped it, it would be EF. And then when you shift it, it would be E. But because it's converted to int before, it's going to be FFFFFFEF. And then you shift it, it's then going to be FFFFFFE. I mean, that's crazy. That's C++, and it comes from C. So this is one of the things that will not be allowed by the new MISRA rule about this type compatibility. Let's go to the next question, next quiz. Oh, I hope you can all read. You also have 30 seconds. Ten seconds. Okay, so the right answer wins again, which is quite good. But still there are some errors. And the fact that there are some errors proves that there is interest in writing those MISRA rules about it. I'm glad that there are some errors. If everybody was right, I would say I spent several days of my life for nothing. So let's have a look at the code. So the first part is just crazy, nothing fancy there. The interesting part is that here you have two stuff that happens when you do an arithmetic operation like that. First, you have promotion, and then you have usual arithmetic conversion. Promotion is going to convert this to int. And then usual arithmetic conversion is going to do nothing because you're going to subtract an int from an int, which is okay. So actually what it does, so now you have an int which is 41, an int which is 42. 41 minus 42 is -1, which is an int which there is no overflow, no underflow, no nothing. It's just an operation with int. So this code is defined and is going to call the overload with int. Surprising. And the next one, which is the tricky one, those ones were easy. Five seconds and just one answer. Okay. One dumb answer at the end. We'll see. This time the right one is not winning. But this one is very tricky. The previous one were useful for real code. This one is just for the nice trick about it. So this value, if you add 3 to it on a 32-bit system, it will wrap around and will be equal to 2, okay? In 32-bit. And what happens is that if you are doing this, what is the type of those literals? Well, there is a U at the end. So the type of the literal is some unsigned type. Which size of the unsigned type? Well, the rule is that there is an order of preferences, which is like if it fits an int, it will be an unsigned int. Otherwise, it can be an unsigned long or unsigned long. The smallest one that fits. So I and j will be unsigned ints here. And so when you do the addition, there's going to be wraparound, and it's going to be equal to 2. So the first answer is going to write 2. But here, it's not an operation in the code itself, it's an operation in the preprocessor. And the preprocessor has different rules than the rest of the code, because why not? So for the preprocessor, those literals are always the longest possible literal, so it's unsigned long. And when you do the operation with unsigned long, there is no wraparound, so it's not going to be equal to 2. Nice one, this one. So back to the slides. If I can find a way to go back to the slides. Yeah, here it is. So I think that the quiz has proven to you that just doing some simple operations is not so easy in C++. So we wrote some rules about types, and what we say basically is that we cannot prevent integral promotion. Maybe if you wrote the language from the start, it would be better to write a language which does not have all these integral promotions. But C++ is what it is. We cannot change it. But what we can do is we can detect when they happen. And basically, there are two cases that are problematic when they happen. Is when you have an integral promotion or usual arithmetic conversion that changes the signedness of a type, because this is what is surprising. And the other one is when it changes the type category of an operand. So basically, is if you are doing an operation, for example, that converts from int to float, this kind of stuff can be strange in some cases. So this is the first thing which is prevented. And the second thing is when you're assigning, we want the target of the assignment to be basically the same as the source of the assignment. We don't want to have implicit conversion in assignments, because we said implicit is not good. And so we force explicitness. If you want to do an assignment with different types, you should add a cast so that you're explicit in what you are doing. It's not exactly that, because we allow the type to be different. For example, on some OS, when int and long are the same size, we allow most assignments from int to long or from long to int because they are the same size. And you are not going to lose value. But even then, we don't allow it in all circumstances because so what we call assignment is not just equal. When you call a function, parameter passing, we call it assignment. When you return a value from a function, we call it assignment too. Any kind that associate a value to a variable, initialization, we call it assignment too. And among those assignments, one of them is special, function call. Why is it special? Because it's used for overload resolution. So if you assign on a system where int and long are the same size, if you assign an int to a long by long L equals int, it's okay, no problem. But if you are calling a function with an int parameter and the function actually is the function selected by overload resolution is a function with a long parameter, it's not going to be okay because the target type is not always obvious when you are doing function calls. So we want you to be even more explicit when you are calling functions. And basically, if you don't do many computation with small types smaller than int, those rules will not affect you that often. So we spend a lot of time about them because some people do this kind of computation, but maybe the higher level advice for that would be do computation with ints. This is what C++ is designed to do. So, do you have any question? So there are many more rules. I don't know exactly how many right now, but it's more like around 200 in total. But I wanted to show you some cases when the changes I think was interesting. Yeah?
So you mentioned that you've not been able to look at coroutines from C++20. Have you looked at anything else in C++20? Or is
No.
it just
When we started the new version of MISRA, C++20 was not out. So we just focused on C++17. And hopefully, so as you may have noticed, there's a big gap between 2008 and next version of MISRA. We hope that it's not going to be the same for the future. So maybe after once this version is released, I'm pretty sure there will be some rest because it's day-long meetings every week. It's not an easy task, so we will rest. But I think that the goal for everybody is that once this is done, we will look at C++20 with the hope of releasing version of MISRA more often. Yeah.
Do you know when the standard will be ready? And is there a pre-release available for that?
Well, as I said, there is one preview which is not public, but which is not private either. It's you should register to be part of the reviewers. And not all guidelines are published to reviewers for now, just the ones that we believe are good enough. And so the MISRA document is organized by section corresponding to section of the standard. And we don't publish part of a section. We wait until the full section is complete before publishing it for this review. So if the registering for the review happened maybe 6 months ago, so if you try to register now, I don't know if it's still possible, but maybe it is if you really want to have a look and maybe to make some comments. And we have not started to review the comments yet, but it's supposed to start very soon. And about the publication date, it depends on many comments and how long we need to process them. I really cannot say right now. We are in the final phase, but that's all I can say. Sorry. Okay, I didn't say, yeah, as I said, do your computation on int. I really meant don't do computation with small types. And size t is not such a small type. So to me, it's okay to do a computation on size t. And if we look back at the talk about in the meetup yesterday, or probably the talk about signed or unsigned for computations, I really don't know yet. I have good arguments in both directions, and I have not made up my mind yet. Yeah.
Solar source, when will you come up with the first code analysis?
Okay, so about my company, the tools that we provide. So right now most of the rules we provide are rules that we design ourselves inside of the company, which in some cases they are related to MISRA 2008. There are a few rules that exactly match MISRA 2008. and some rules that are inspired from MISRA 2008, but with differences because at the time we believed that they were too strict in many cases. We have plans to support this new version of MISRA, but right now it's we have not released anything like that, and we are in discussion with between my company and the MISRA consortium about what we are allowed to do, because MISRA is not an open standard, so we need to sign an agreement to be able to develop routes that match MISRA. So it's a work in progress. And basically, it's not totally validated yet, but there are several companies, and inside of the MISRA group, there are basically people who come from the automotive industry and people who are tool vendors. And I think we might take an approach which is different from other tool vendors, which is at SonarSource, we really believe in making tools for developers, not for people from QA who want to certify stuff. So we might, we have tools which are quite well integrated into the development lifecycle. For example, we have ways to block pull requests if you're not happy. You have one tool that works inside of the IDE. And so our goal might not be to have a full coverage of MISRA, but to propose some tools so that in the everyday work, people will write code which is mostly MISRA compliant. And then maybe if they want to go to the final stage of compliance, we don't know if our tool will be the best one or not. Maybe another tool that runs for 1 week will be required at that time. But we want to be, our main focus is really to be fully integrated into the development lifecycle and have a tool that runs fast and gives answers fast, because we believe there is high value in that. So, any other question? Well, thank you.